My name is Jason Dobies. I'm an OpenShift developer advocate at Red Hat. If you've never heard the term developer advocate, it usually means that I do cool stuff with OpenShift and then run around the country presenting it. What it has meant since COVID started is that I stand in these four walls staring at this camera presenting it. So getting a little stir crazy from that, but that's okay because I get to talk nerdy with you guys today. I'm really excited about it. I do see the polls coming in. I have two questions in here just to kind of level set. I have a lot of content I want to talk about or I can talk about, but I want to make sure I'm skewing it to where the audience is and making sure you guys are up to speed. So for the top two, a very high level crash course. A container is a way of running what is called an image, and that image bakes in everything you need to run your application. So if you've never used them and you're thinking that sounds kind of like a VM, you're not wrong, except there's no virtualization layer. So it's a lot more lightweight, a lot quicker to stand up. And instead of thinking in terms of I have 6, 8, 10 virtual machines, now we're thinking in terms of I have 100 containers. I mentioned the image part of it because part of the development process is I write my code, I create what's known as a Docker file that describes that image. I build that image, I push that image to some kind of repository, and then that's how I share it out with people and they can go and manually run that image, which becomes then a container. And I point all that out because a lot of our dev tooling is meant to expedite that rather cumbersome process. So we'll get to that in a second. What is Kubernetes? Kubernetes is a way of running containers more simply. It's an orchestration engine. So instead of me saying, I have 10 machines I want to run containers off of, and I'm going to SSH into this one and start these 3, I'm going to SSH into that machine and start these 5. Instead, I'm telling Kubernetes, hey, I would like you to create me 10 containers from this image. And we let Kubernetes decide, hey, this is where I'm going to distribute them and make sure they're still running and so forth. What is OpenShift on top of that? Not to reiterate a lot of what Troy said, but OpenShift is our enterprise version of Kubernetes that does the normal Red Hat hardening of things, but then layers on a bunch of tools. Some of those tools are what I'm here to talk about today for the developer side. Now you should see a second question here, asking if you find yourself to be more of a GUI person or more of a CLI person, or if you don't particularly have a preference. And I have examples in both cases. Many things, if not all, can be done on both. So just want to get a feel for if I should spend my time on one versus the other. You guys are almost universally going one at a time here to keep things even. So this does help. This does help me kind of bounce around between the two, and that's fine. All right, so we'll duck out of that for now. Let's move into the first demo. So if you use Kubernetes, there's a tool called kubectl or kubectl, and that is your CLI interface to interacting with the Kubernetes cluster. OpenShift has its own CLI, its own interface called OC that is syntactically similar to kubectl, but also adds in some OpenShift on top of that. So if I wanted to use a kubectl command in OC like get pod, now this should be return any pods that are running inside of this namespace. If you're not familiar with Kubernetes, pod is, for my purposes, synonymous with the container. There's a little more nuance to it, but given time constraints, I'm not going to go too deep into it. Point being, OpenShift has this OC client. As you start to get started with OpenShift, you're going to see the examples in the documentation talk about that. But that's not what I want to talk about today. We have another tool called Odo. To be honest, nobody knows how we pronounce it. Odo, Odoo, Odo. I'm probably going to bounce between all of them because I can't make up my mind. Odo is meant to be a development tool for facilitating writing and testing and deploying your applications. And that's what I'm going to spend the first part of this demo talking about. So what we're looking at the top here is a very simplistic Python application. In fact, let me take a step back and paint the big picture of the application we're deploying. It's a very simple two-stage application. We have a front end written in Node.js, and that is going to present the user with a concession stand kiosk where you can select hot dogs and hamburgers and stuff. Once you submit that, the order goes through and is sent to a REST API backend written in Python, and that's what we're looking at now. And I'm going to go and I want to deploy this application inside of my running OpenShift cluster. So I've already logged into the cluster. Again, what I said earlier, that you would traditionally have to build an image, and that includes writing a Docker file and building the image and pushing it. We're not going to do any of that. You'll notice I don't even have a Docker file here. So we're going to use this auto command. We're going to create a new project called concession. And that just chains down to the underlying OC command. So we have a new project, which is the OpenShift term. Namespace in Kubernetes is basically synonymous. So we've created a new project, a new namespace that we're going to create this in. Now, there's a couple of concepts in Odo. For our purposes, we care about components. And component is something that you can think of it as a runtime for my application. And as I do a list of them, you can see that we have a bunch of built-in components, Python and Ruby and so on. We're going to use Python in this case. So I'm going to tell Odo I want to create a new project. We're going to have it based on Python, and we're just going to simply name it backend. Because again, we're working in the backend side of things. And this is how we're going to refer to it later on through Odo. Now at the bottom, I'm going to set up a watch. All. OC get all is going to return most resources in the namespace. And again, since this is a brand new namespace, make sure I'm the right project. Since it's a brand new namespace, we don't see anything. So when I run this Odo push, you should see some stuff start to get created on my cluster at the bottom. So it's creating our image stream, which is an OpenShift concept for where it actually, let me take a step back. It's an OpenShift concept on top of images, and it uses tags to denote particular images that are related to each other, and then it stores their location. So some of them may be stored inside of OpenShift's registry, some may be on Quay.io, some may be on Docker Hub. And we create our deployments and our services. We find that it has started this pod for us. Now, again, if you've ever done this in Kubernetes, the first thing you would need to do is write the YAML. First thing you would need to do is create the image. And then you write the YAML that defines all of these pieces and references the image correctly and so on. Here we just said, I want to create this Odo component and I want to push it up to the server. So at this point, we have this running pod. I can use Odo to check out the logs on the pod. And it's going to give me some information on the build process, because what Odo is doing in the back end is not just starting up a container inside my cluster, but it's also building my application code. In Python, this largely means working with the requirements.txt to make sure it pulls down the right dependencies. I don't want to get into too much of the details in case you're not particularly Python friendly people, but and then it's going to start our application. So it's running this simple app.py. I can also, and this is more of a tangent than anything, using OpenShift, I can log into the running pod. So this OC_RSH command, and then at that point, I can look around and see what's running on my pod, see the files if I need to. Let me be clear though, I will be alternating some OC commands in, but when you distill down what I'm doing in terms of the deployment and the development, everything is done through Odo. This OC get all is simply for demonstration purposes, so you see the pieces getting created. But at this point, now we have our backend deployed. There's no external URL to it, but that's very intentional. Our REST API is meant to be only accessed by the front end, so we're going to leave that tucked away inside of OpenShift. Within the cluster, the front end is going to use the internal DNS to find the backend, but we're not going to expose it publicly, and that's very intentional. I guess I'll stop there for questions as I set up for the front end. So anything before I move on? Okay, I've changed over to our front end directory. We're going to run this create command again. So this is a separate Git repository. It's a separate project, a separate code base. We're making a new component for it of type Node.js. And this time we're also going to create a URL because we want this to be accessible from the external internet. And I'm going to push. And again, you'll notice this has a Git-like syntax where I'm making local changes. Those don't appear directly on the cluster. Those aren't running until I go through this extra step of pushing them out there. We're going to see a couple of different things get pushed over the course of the demo, but it's important to understand that model, that it's got this Git-like interface, and we're not manually building the images. We're pushing this code up to the cluster and letting it handle the pieces we want. So the push command has come back. We see at the bottom here, the front end pod is running. So we want to find out, how do I actually access it? And it's going to give us the URL. And if I hop back to the browser, we come up with our basic concession stand interface. Admittedly, not the prettiest thing. I'd like to say I didn't design it, and I didn't, but I also couldn't do any better, so that really doesn't say much. And we'll place a very simple order, and we should see that it's going to fail. And that's not a surprise, because so far we've deployed our front end, we've deployed our back end, but we haven't actually told the two about each other. So there's no way at this point for the front end to understand, here is how I actually access the backend repository, or the backend REST API. And we have a command for that. It's called odo link. And what I've told it here is, I want this front end to be aware of this backend application. And this is the port it's running on. And you'll see here the application to redeploy. Because what happens is it's done through an environment variable configuration. We're actually very verbose in describing that up here during the actual link command. Those two environment variables are injected into the front end component. And now my code is written in such a way that I'm going to look for those two values when I attempt to connect to the back end. Now, in OpenShift and Kubernetes, any configuration change is going to cause a redeployment of my image or of my container. So this is why we saw that terminate step and recreate. I'm specifically pointing it out because we're not going to see that every time. But for now, yes, we've updated the configuration. It has injected those values for us. And if I go back to our application, we'll throw a salad in there and I place the order. Now we get to our thank you page. And the way the thank you page works is the REST API stores the order itself and then returns an order number. So if I place a second one, we're going to increment to a separate order. The fact that we're on 103 makes me wonder if someone is playing around with this in the background, which is totally fine. Okay, so that's linking our components. I do want to mention if we just log into that pod, we see those two environment variables have been introduced. So again, just kind of reiterating that point that that linking process is used to take the necessary values out of the back end, inject them into the front end component. And now it is on me to have my code written in such a way to look for these, but that's really not a difficult thing. To be honest, that's the paradigm in container development. That's how we customize containers rather than constantly rebuilding images. We tend to inject a lot of values through environment variables. Questions before I move on?
Just a quick question about where this stuff is running. You know, is this all on one machine? Is it split across different machines, different data centers? Like where does that configuration happen before you even get to this point?
Sure. Now I'm going to give you an answer, but I promise I'm going to give you a better one. The first answer is I shouldn't care. I know that I have access to a cluster that I've logged into, and if that's running in GCP, if that's running in AWS, at the end of the day, those are OpenShift configuration things that they can hide from the developer. And I just know that I have my project capabilities in terms of quotas and resource limits, and I leave it up to OpenShift to determine where to put things. And if that means single cloud, hybrid cloud, bare metal, it doesn't matter. Now, I don't want to say that's a blow-off answer and just be like, go away, it doesn't matter. So what I have here is yesterday I installed OpenShift on GCP myself, basic install of 3 masters and 3 worker nodes. And I've just connected to it. So I logged into that before starting the presentation. I just did an OC login like you normally would. Now, I'm not sure if this was part of your question, but if you're asking where the Odo specific stuff lives, and let's say you were, because that's a really good segue, there is this .odo directory that gets created inside of your source code. I see you laughing over there, Philip, at that comment. And I got to point out, I like your gaming chair. I have one right behind me too. Okay. So it creates this Odo directory in the project source code. That's relevant because I can commit that to my Git repository. And new developers now who check out the code can simply run odo push. It'll read those values, it'll create my project, it'll create my deployments, it'll push the code up. So now we've got this really unique way of handling multiple, I shouldn't say multiple environments, but a consistent environment across multiple developers. And we're getting away from that, oh, cool, you're new to the team. All right, take 2 days, get your setup running, and then we will talk about actually you doing productive work once you can get things running.
So Jason, can I just interrupt you for a second? So
absolutely.
The presentation we've seen so far is very deeply focused apparently on devs, and I'm not too much acquainted with OpenShift, and I have a question which is very basic, maybe very stupid perhaps, but what is the key difference? Why, the kind of the rationale why I would want to start developing or have my team start developing or creating applications on OpenShift compared to Kubernetes?
There's a lot of ways I can answer that. Let's jump into one that I have readily available is our UI. So this is the OpenShift console. So earlier I asked if you guys were more GUI or CLI focused. This is logged into the exact cluster I'm using. So we can see the pieces that we've just deployed through Odo. There's a lot of information here. Some of it, I can re-trigger some things so you can see it moving. You'll see it a little bit in the demo. That's going to give us this full-blown graphical view of my application. So we can see the running pods. If I click through, we can see all of the logs. One thing that still makes me giddy in this really nerdy way is I have this in GUI terminal where I can be directly inside of my pod, just like I did from the CLI, but it runs within the console. So we have all of our console functionality there. We have all of this tooling built on top of it. Odo is one of these. We're going to see source to image builds in a second. We can also, and since I'm in the GUI, let's jump around a little bit my presentation. So what we're looking at is the developer perspective on top of OpenShift. There's this split between administration and developer. No surprise, I prefer the developer, but it really depends on what it is you're trying to do. So from within here, in this concession project, and this isn't going to hurt anything to go on this tangent here, but if I go to add, you can see a variety of different ways we can introduce new applications and new services to our cluster. And one thing I want to show you is just adding a database. So in this case, let's add a MariaDB database. And if we took some time, we can read through the description of everything going on. But for all intents and purposes, just trust me, this is a MariaDB database. So I have this configuration into the database, and I very securely defaulted everything to JDOB, but that's fine. What it's going to do is use Red Hat certified images to stand up this service for us. So possible through Kubernetes? Yes. If you hunt down the deployment, if you make sure you're using a safe version of MariaDB's image, if you type in all of the different YAML and figure out how to do it, having this available as a built-in template is very handy as a developer because I now have my database running. And I'll go back to answer your question in a second, but I have, this presentation is so weird because I don't have the charisma of a magician, but a lot of this ends up being this kind of hand-wavy, like, ta-da, look at this. But I don't have MariaDB running on my system right now. In fact, I'm going to show you. Oh, it is running because I restarted my computer. Hang on. We'll stop MariaDB. Let's pretend the presentation is that. So I'm going to stop MariaDB on my running system. For all intents and purposes, imagine I didn't even have it running, but I still wanted to use it. So developers, again, you come into a project and you take a couple of hours, couple of days to get everything set up, and you're downloading libraries and runtimes and all of this extra stuff. Here I've stood up this database in our cluster. I'm going to run OC port forward. I'm going to specify the pod and the exact port. So from my computer's perspective, if I were to go to localhost on 3306, it should be forwarded over to the cluster connection for the database and appear as if I was connected to it locally. So I log into my localhost, just the default port, and you saw this handling connection. So I'm in here, I can do any of the database stuff I need, but I don't have MariaDB running on my machine. Arguably, I could not even have it installed if I wanted to go that route. That was more of a tangent than actually answering your question. I admit that. But while I was in here creating the database, I figured I would take that steps. So we have,
Jason,
yes.
Before we go forward, let me interject a second. Would you say that the value add for a person to use OpenShift container platform is that from an administrator's perspective, I can have all these predefined images ready to go, libraries, etc. Do all the front end lifting up front that's already approved, and we have it secured. We understand where it is, patch levels, etc. Then flip it to the developer side. They know these are good objects that they can go and reach out and pull from without having to worry about what's going on, pulling it from an unknown repo somewhere, etc.
That's exactly right. And let me elaborate on that a bit. I don't have time today to go into a full-blown operator discussion, but Operator Hub is a way of installing this extra piece that is going to let me install and manage other services. So if we go to databases here, we can see things like Cockroach and Couchbase and so on. I mention this because it's the exact model you were talking about. As an administrator, I can say, I'm going to grant this developer access to Couchbase. So I'm going to install the operator and make it available to their project. Now that developer can go in and say, I want to create a new Couchbase resource. And a couple seconds later, that Couchbase database has started. And that's a way of administration to say, yes, these operators we are okay with in our environment for whatever reason. Compliance, or they know it's gone through certification or whatever, but it then introduces them over to the developer side of things. Something else to point out is things like resource quotas and limit ranges. And I'm not going to create one right now, but actually the example works well enough. If I were to add this limit range as an administrator, I can say that this namespace, can only go up to half a gig of memory. I can limit them on CPUs and so on. I have a separate demo. I'll take 10 seconds to explain it, but if you've ever seen the movie War Games, I take a couple scenes from that movie and I replicate them in modern technology. And at the end of that movie, sorry for spoilers, but it's like a 30-year-old movie, so that statute is well over. They crashed the Whopper system by having it play too many games of tic-tac-toe. I replicate that on OpenShift by throwing tons and tons of containers at it and showing what happens when we fill up the nodes. One answer to that in the demo is to set up resource limits. So now as a user, I can't possibly bring down the entire cluster by taking up too many resources or deploying too many containers and not cleaning them up, because as an administrator, I've kept these caps on my developers. But again, keep in mind that this is a resource limit rather than a request. So we're trying to get away from the stories of, and we hear this from customers where we run similar polls to like I did, and we ask developers like, hey, when you request something from IT, how long does it take to get it? And the average answers are coming in between 2 and 4 days. This makes it much more self-service for the developers, where IT doesn't have to decide like, yeah, we're going to allocate and create that VM and get it over. All of that's available to the developer to do on their own, but IT and admin operations still has this ability to say, all right, well, slow down. I don't want you taking up 32 CPUs or anything like that.
Another thing, and maybe I'm getting ahead of where your presentation is going to head, but another thing that I'm concerned about as an administrator is my developers launching things that are incredibly insecure. And, I would like to put in policies or something to prevent that. Is that something you would do from this UI, or is that something you would do from another portion?
That's not as easy to do in the UI. There are ways though. The inside of OpenShift, and this is another difference from Kubernetes, you install Kubernetes and you get the orchestration engine, but you don't have an image repository. You're still, every example you see is going to pull things from Quay.io or Docker Hub. OpenShift actually has an image repository running inside of it. What happened is, as I was doing that build with the Odo push, it was creating an image and storing it in there. I have the ability to push things there and then limit where developers can pull images from. So that is one way of saying, all right, I don't trust my developers, and I have a very strong developer background. So you're not wrong in that, because if it's new and cool, we're like, yeah, I'm gonna try it. What could possibly go wrong? And meanwhile, ops people are in the corner crying because I say that. So it's a very valid concern, and that's one of the ways that we have for limiting those types of things, yes.
That's probably not the only reason ops people are in the corner crying, but it could be one.
I did about 15 years in development before I moved to advocacy. I've made many a developer cry, or many an operations person cry, which is funny now that I'm in this kind of DevOps world preaching like, no, you guys can get along. I promise. It's not really that scary.
Can you also scan the images that are uploaded to that repository for vulnerabilities before you allow them to be used?
Yes, so it's ultimately a Quay repository running inside, and there's Claire. I'm afraid I was going to remember it. Claire is a product for scanning images in a repository, and then you can put the hooks in place where they're scanned on upload. We also, without going into crazy detail, have a very, very strong partner ecosystem. I spent some time there a couple of years ago, and we have outside products. I don't want to get into political battles of naming any, but you can easily find them on our site. But we have partners we've integrated with who do image scanning, and we're able to accomplish the same type of thing with their products. So people who have an existing infrastructure investment in kind of the major ones out there, and I'm sure you're picturing a few at the top of your head, they have the ability to integrate with OpenShift as well. So we have our front end deployed. We have our back end deployed. We've shown that they can speak to each other. Now, again, to circle back to the idea here is that we're talking about development and how quickly we can get code running in a system and not having to go through podman build, podman push, create the deployment, and so on. We've seen that with existing code, we can do that. What else can we do here? So I'm going to go and edit my index page. Apologies that this is going to be slightly unreadable because I normally work with a dark background, but this is fine. So we're going to add in a hello tech field A that is so light that we're going to see if I've made any typos when it actually goes live. So we've changed some code. That's the point of all of this. Change some code that we can actually see running in the server. And if I go back and hit refresh, no surprise, those changes aren't there. If I simply run another auto push, and I'll set my watch up on the bottom again, what's happening is it's pushing up my changes to doing a diff of what has changed, found that one file, and you can see it ended already, and you can see that there was no redeployment of the container. It stays running. I don't have to eat the cost of shutting down the container and starting a new one up. And if we go back and hit refresh, ta-da, we have our message up there. Now, as a developer, this is awesome, being able to make a single change, because let's be honest, a lot of development comes down to, I type my code, I think it's good, it breaks. I make a single character change because of a typo, and I want to see that change live. Or I don't know what I'm doing, so let me just throw some code at the wall and see what sticks. I'm going to say that's common developer practice. I really hope I'm not outing myself as a crappy developer, but typically you see a lot of those kind of rapid changes. So being able to just make a quick change, auto push, make a quick change, auto push, without having to rebuild everything is huge. It is absolutely game changing in terms of the speed at which I can see new changes get out there. To make it a bit faster. So I'm in the front end directory, which is going to give us access to this auto component. And I'm going to set up a watch. And we're going to edit this to the next page again. And I'm simply going to put a bunch of exclamation points because I have no creativity whatsoever. Now, as I hit save, I want you to keep an eye on the bottom pane. That's my running watch that Odo is saying, I'm going to keep an eye on everything in this directory. When something changes, I'm going to automatically push that up to the cluster inside of the running container. That's finished. I hit refresh, and we have my exceptionally corny multiple exclamation points example up there. So now, not only can I edit code without having to build the image, I don't even need to manually think about this push process. And I have this effectively a link into the running application where I just type and the changes are fairly immediate.
Is there a kind of validation code before pushing the code? So I mean, if I'm a developer, sometimes it happens that by a typo, by whatever, something will happen. And sometimes I recognize it when the containers is live. Is there any kind of, I mean, testing code or something that I can plug into this push before bringing my application live?
It's a really interesting idea. But the short answer is no. What you're talking about there is a little bit more of a CI/CD platform, even though a CI/CD platform is a bit heavyweight for that short example you mentioned. But I'll use that as a jumping off point to say that if you did want full-blown CI/CD, OpenShift pipelines, and again, this goes back to OpenShift versus Kubernetes, OpenShift has this pipeline, which is a built-in CI/CD system. Quite possibly my favorite GUI pages inside all of OpenShift, because the way you graphically see the different pieces and which ones are run sequentially and which ones are run concurrently. I at the time when UI first showed it to me, I was like, this is badass. And then they actually took that quote and used it in the 1,000 slide decks after that with my name under it. So I got to be careful what I say in front of the UX people. But that's obviously a heavier weight answer to, do I want to do linting and test runs and stuff like that? This Odo watch is a little more lightweight than that. It's not like a full-blown Maven that's going to run multi-stats. It's just going to get the code out there. It's an interesting idea, though.
Because I was thinking about, place this in a non-production environment. It's fine, but in case of production environment, it could be a little bit,
It could be a lot. That was actually very generous to say a little bit scary, because that should be fairly horrifying to think of using Odo like that in production. And that's where this differentiation comes in. And looking at the clock, I'm actually going to make this my last point. Odo is meant specifically for this type of development where I'm testing things, I'm seeing if they're working. You notice that it's got a Git-like syntax, but it's not actually using a version control repository. So all of this stuff takes place before I, as the developer, are saying, this is finished, I'm good with this, let's get this into the repo to share with the world, because I'm pretty sure it's not going to set anything on fire. At that point, you're going to want a CI/CD system to pick it up out of version control and run a lot more hardening and testing and things like that. And that's where something like Jenkins, which is a traditional answer to this, or OpenShift pipelines, which is this cloud native way of doing the same thing, and have that built in where it's going to take it to the next level and then make the decisions on, do I deploy this just to a dev cluster? Do I deploy this to QA and to prod?
Yeah, maybe I have one question, because there was a lot of CLI orchestration deployment of stuff, but there had to be something pre-configured, like the containers itself, the configuration of a container, like the persistent and the non-persistent storage. Is this also done here through the GUI, or is this also a CLI on the back end?
Either. There is a CLI for OpenShift storage, dealing with things like persistent volumes and stuff like that. All of that can be answered. I don't think I'm able to see it. I can see it from here through the CLI as well. So I'm saying, show me all persistent volumes, and this is showing the stores and which ones are bound and so on and so forth. So whatever you're more comfortable with. I will quickly point out that I can export that to YAML, and this gives me this infrastructure as a code type of concept where I can now take these persistent volumes and version track them, because they are just text, they are just YAML. And if I were to really poke around the UI, I could find this exact volume that we're looking at here, but it's really the entire spectrum. Do I want to work strictly in a GUI? Do I want to work in a CLI? Or do I want to really be careful about things and version control my infrastructure?
Okay, now in the GUI, that was interesting to see that there was a drop-down box between the administrator and the developer. So I'm going to be a little more candid than I probably should be. I don't personally like this. I think that the amount of times we've done DevOps talk, having this hardline distinction feels a little counterintuitive. I will say that in practice, once you're using it, it makes a lot of sense, where especially as a developer, that stuff I'm not really going to need bogging me down.
I'm going to want this type of view where I can see my applications. I didn't really get into a lot of what you can see in this right-hand side if you're doing builds and stuff within OpenShift, but it does feel a little old school, for lack of a better word, where you have these kind of fierce lines, but ultimately the differentiations do make a lot of sense.